Okay, so we left off with the examples. That's all we had left to finish for this section. So here we are, we have to condense these logarithms. So we're given more than one, and we're going to make it as small as possible. So really, there's only one step here. We're going to take this, we're going to say, okay, we have the same base of our logarithm 2. We can apply the addition property. So if I have two logarithms that are added together with the same base, they become one logarithm, and you multiply the numbers together. This becomes log base 2 of 42. So next we have two logarithms with the same base, and I'm subtracting them. So this becomes log base 3. When I subtract, I divide. So 21 divided by 7. Well, that's log base 3 of 3. Well, log base 3 of 3 is our identity. So that equals 1. Which makes sense if we look back at our definition of a logarithm, because this would say 3 to the first power equals 3, which is true. Next, we're going to expand logarithms. So here we're given one logarithm. We're going to break it up into multiple, depending on how many we need. So each one of these are going to have a base of 3. So it's going to be log base 3. They're multiplied together. So when I split them up, I'm going to add them. So log base 3 of 2 plus log base 3 of x plus log base 3 of y. That is expanding. Here's our next one. We have log base 7 of 2 over 3, or 2 divided by 3, or 2/3, however you want to say that. And here I have division, so I'm going to write log base 7 of the top, the numerator, which is 2, minus log base 7 of the denominator, which is 3. So putting it all together, we're going to solve equations. First, we're going to condense or expand, and then we're going to use our property of equality of logarithms that says that if you have the same base, then what you're taking the log of is equal. That's what we're trying to get to. So we're going to condense and expand to get one logarithm on one side, one on the other, with the same base, so we can set what we're taking the log of equal to each other. So, first problem, we have an addition. We have the same base here. So this becomes log base 4. When I condense it, they become multiplied together. So 9x equals log base 4 of 27. My bases are the same, so I can set what I'm taking the log of. I wrote 24. I can set what I'm taking the log of equal to each other, so 9x equals 27, so x equals 3. Next, a little bit more complicated, but I've got 2 times log base 10 to the 6th minus 1/3 log base 10 to the 27th equals log base 10 of x. So the first thing I'm going to do here is apply my power rule. So my power rule says that if I have something out front, I can make it my exponent. So I'm going to make that my exponent. So it's become log base 10 of 6 squared minus log base 10 of 27 to the 1/3 equals log base 10 of x. Now these are all log base 10. That's our common log, so we could technically write these without the base, because log base 10 is so common we just use plain old log. But I'm just going to keep going log base 10 so you can see. Alright, so I'm going to evaluate this now. So we have log base 10. You don't have to evaluate, you can actually apply your properties beforehand if you want to. It doesn't matter either way. Log base 10 of 36, because that's what 6 squared is, minus log base 10 of 27 to the 1/3 power. Well, over on the side, 27 to the 1/3 is the same as the cube root of 27. So the cube root of 27 is 3. So this is log base 10 of 3 equals log base 10 of x. So I have a subtraction problem. I want to condense this. And when I have subtraction, it condenses to division. So log base 10 of the first one is the numerator, divided by 3, which is the denominator, equals log base 10 of x. So now from here I can actually say, okay, my bases are the same, so I can set what I'm taking the log of equal to each other. So 36 divided by 3 is 12. That equals x. And if that went too fast, go rewind a little bit, look at it again. All I'm doing is applying the properties, trying to get it to where the base is the same so I can set them equal to each other. And here's your homework.